The last thing we're going to do here is we're going to look at some Ohm's law, series and parallel, one last time. So we're going to take a look at a series circuit. Our power source is 300 volts. This is series. Our load 1 is 100 ohms. And our load 2 is 50 ohms. Basic electrical diagram there. So what do we know about series? We know that the resistance adds. So if we add these two together, we can simplify this circuit and do a single one with our total of 100 plus 50 is 150 ohms. So that is our R total is 150 ohms. Now, because I have a simple circuit, I have voltage and I have resistance, and I can now use Ohm's law to solve for this. Third quantity, I equals V over R, which is going to be 300 volts over 150 ohms, which is 2 amps. So there's 2 amps flowing around this circuit, okay? 2 amps. So my total voltage for this circuit was 300 volts. There we go. My power is VI, so 300 times 2, 600 watts. Okay. We're now going to take this circuit and we're going to back it up, and we're going to back up the information into the circuit before we broke it down. Because for this one, I have voltage, current, resistance, and wattage. So I apply it to here. This is series, and we learned in series that current stays the same. So here we said we had 2 amps, which means 2 amps runs through this conductor, 2 amps through this load, through this conductor, 2 amps here. There's 2 amps running around here. So we know that each one of these resistors gets 2 amps. Okay? So they want I1, 2 amps, I2, 2 amps. Okay? So now I'm here again. I can solve for voltage here, because voltage is I times R. Okay? And so if I take 2 times 100, I get 200. So this one is 200 ohms. And I can also do the same here. Voltage equals I times R, which is 2 times 50, which is 100 volts. I'm sorry, did I put volts there? 200 volts. Okay? And finally, power equals VI. So I've got 2 amps times 200 volts. This one is 400 watts. Power is V times I. So the second one is 2 times 100 is 200 watts. Now a couple things we just want to take a look at. When we looked at our simplified circuit here, we said it was dissipating 600 watts. Does that make sense? Well, according to this resistor is dissipating 400 watts of heat, and this one's 200. So yeah, 400 plus 200 equals 600. That seems to make sense. And then what about our voltage drop? Because these are in series, this is going to drop some voltage, and then this is going to drop some voltage. And the sum of those voltages has to equal the source. Let's check that. So our source voltage was 300. And sure enough, we have the first one dropping 200 volts, the next one dropping 100 volts. So 200 volts, 100 volts, and guess what? That equals 300 volts. So all our numbers look pretty good on this one. Okay? The next page is the parallel circuit. So you had power of 300, power source of 300 volts, and you had a resistor here of 100 ohms, and you had another resistor, this time in parallel, of 50 ohms. Okay? Well, what we can do on this is we can simplify it like we did before, a little bit differently, but we want our simplified R total right here. So what is R total? Well, now we need to work with reciprocals. So we know that 1 over R total equals 1 over 100 plus 1 over 50 ohms. Okay? We need a common denominator, which would be 100. So we're looking at 1 over 100 plus 2 over 100. That's a common denominator. And that is equal to 3 over 100. It's at 1 over, so we need to flip that. 100 over 3 ohms. So it's 33.33 ohms. Okay? I can now go I equals V over R again. 300 volts over 33.33 ohms equals, I'll put my calculator out here, and I'll go 300 divided by 33.33, 9 amps. I'm just going to round that off to 9 amps. So I know my voltage here was 300 volts. My total resistance was 33.33 ohms. The current flowing through this one is 9 amps. And power equals E times I. So I take my amperage right there, my VI, times 300. I get 2,700 watts. All right. Now what do? I apply what I know up to here. Well, these are in parallel. So the voltage from here stays the same. And it's obvious that I have a 300 volts here, so each one of these is getting to 300 volts. The last time the current stayed the same, and this case the voltage stays the same. So the voltage on the first resistor, 300 volts. The voltage on the second, 300 volts. Okay? So at this point, I know R and V. And I'm trying to get I. So I is V over R. So if I take the first one here, I have I equals V over R, which is 300 volts over 100 ohms. It looks like this would be 3 amps. And the second one here, I is V over R. So in this case, it's 300 volts over 50 ohms is 6 amps. Okay? And then my power is E times I. So 300 times 3 is 900 watts. And then 300 times 6 is 1,800 watts. Let's see if it makes sense. So we said the whole circuit here was dissipating 2,700 watts. If we look at our broken down circuit, we have this one dissipating 900 watts and this one 1,800 watts. If you add those two together, you get 2,700. So that looks pretty good. Our voltages stayed the same, so those look good. And now let's do our amperage. So according to this, there was 9 amps running through the conductor through the loads and back. So if I had 9 amps here, it looks like they split, where a portion of the amps goes one way, a portion the other. The amps are going to go the path of least resistance. So this is least resistance, so this is supposed to be getting a higher amperage than that. It looks like this one was getting 6 amps, and this one was getting 3 amps. Well, that adds up. 9 is equal to 3 plus 6. So 3 plus 6 equals 9 amps, and that all matches up. So that was just one more series parallel review.